The problem that we're trying to solve with cancer research today is trying to stop it from coming back. Metastatic cancer's such a problem. We know that if a cancer does spread, the treatments today are not curative.
In the last couple of years, the shift and the changes in AI and what it can do have opened up whole new ways to think about medical research.
You know, worldwide, there's over 600,000 cancer deaths per year, and 90% of those deaths are coming from metastatic cancer. How do you understand the one cell that is not getting eradicated by our current treatments? And so how do you kind of find that needle in the haystack to stop that cancer cell from coming back?
So at Garvan, we're focused on immunology, cancer and genomics, and the intersection of those fields and how they can help prevent, treat and diagnose disease. And so to do that, we use AI in every part of our work, right from the research side and through to the way that our institute runs.
What we're learning from AI is the power of collecting all of the data and making sense of it. We can collect so much data from a single patient that the ability to process that is impossible for a human and unbelievable with what you can do with AI. So if you have a very small tumour, that can be close to 1 billion cancer cells. And so when you start to think about how to understand what that means, it's beyond our comprehension. So what we learn is that we can now look at each of those single cells within the tumour. And within each cancer cell, we can now gather around 3,000 pieces of information on one single cell. This kind of AI is going to transform patient care and patient outcome.
So if we think back, the Human Genome Project, we sequenced a single human genome. It took 13 years. It cost $2.7 billion US. What's changed now is that we can go and sequence individual patients. We sequence 100 genomes a day just at Garvan, and that's incredibly inexpensive. We can sequence a patient genome for $100, $200 US. So the biggest change I've seen with the growth of AI is the ability to understand that data. So AlphaFold from Google has allowed us to be able to predict the structure of proteins. And this is a really fundamental problem in biology, which I really didn't think would be solved in my lifetime. One of the most promising applications of AI is being able to design and develop new antibodies. When someone does develop cancer, one approach to treat it is to use targeted antibodies that can recognise the cancer cells and then help your immune system fight the cancer. The patient stories are what motivates me every day to come to work. There's one little boy I think of in particular who had his genome sequenced at Garvan using tools that leverage AI. And the team was able to identify the gene that was causing his very, very severe immune system defect and identify a drug that would treat it. And he went from being literally at death's door to being a happy teenager at this stage. So AI in medical research is really all positive from my perspective. We're seeing it changing the capabilities that we have, the pace of the work that we do, and really opening up whole new ways of working that are just going to have positive impact on patients.
I hope that we can really start to embrace the power of AI and bring it into every different step of the patient's journey. So at the moment, a lot of the pieces of information are disconnected. If we bring AI in, we can really start to connect the dots. So I definitely think there's a future where we're going to be able to predict who will get cancer and then stop it before it even starts.